Hi, today we are going to discuss some of the angles related to solar radiation geometry, that is, Sun Earth angles. In solar radiation geometry, the main angles are incident angle, declination, so altitude angle, zenith angle, solar azimuth angle, surface azimuth angle, and some of the technical terms related to solar radiation geometry, that is slope, day length, local solar time. So first we discuss incident angle. Suppose there is an angle between an incident beam radiation and normal to the plane surface. Then the equivalent flux or radiation intensity falling normally to the surface is given by I cos theta, where theta is called incident angle. And we can say that the changes in the location of the sun have a direct effect on the intensity of solar radiation. The intensity of solar radiation is largely a function of the angle of incidence, that is the angle at which the sun's rays strike the earth's surface. If the sun is positioned directly overhead or 90 degrees from the horizon, the incoming insolation strikes the surface of the earth at right angles and is most intense. This figure is already explained. It shows the effect of angle on the area that intercepts an incoming beam of radiation. Next term is the declination. Declination is the angle between the equator and a line drawn from the center of the earth to the center of the sun, and it is denoted by delta, and it varies seasonally due to the tilt of the earth on its axis of rotation and the rotation of the earth around the sun. If the earth were not tilted on its axis of rotation, then the declination would be always 0 degree. However, the earth is tilted by 23.45 degree and the declination angle varies plus or minus this amount. So in short, we can say that it is the angular distance of the sun's rays north or south of the equator. At equinoxes means equal nights. The nights are equal when the declination of the sun is 0. At equinoxes, the sun's declination would be 0. Actually, this declination varies from year to year slightly. It is 0 on the 2 equinox days of March 22 and September 22. The declination in degrees for any given day may be calculated by the equation of Cooper, that is delta equal to 23.45 sine 360 by 365 into d plus 284, where d is the day of the year. Suppose we are considering a date June 21, 1988. It is the 173th day of 1988. So here small d equal to 173. That means 31 plus 29 plus 31 plus 30 plus 31 plus 21. So in short, declination can be taken as the angle between a line extending from the center of the sun to the center of the earth and the projection of this line upon the earth's equatorial plane. So next angles are altitude angle and zenith angle. Consider this figure. The angle between the horizontal and the line to the sun is denoted by the altitude angle. The complement of this angle is called zenith angle, that is defined by the vertical and line to the sun, that is the angle of incidence of beam radiation on a horizontal surface. If we take altitude angle as alpha, then the zenith angle theta z can be taken as pi by 2 minus alpha. So here the two angles can be seen, altitude angle and zenith angle. Again I am explaining the definition: angle between the horizontal and the line to the sun. The altitude angle varies as 0 degree less than or equal to h less than or equal to 90 degree. Next definition is azimuth. It is an angular measurement in a spherical coordinate system. Because the vector from an observer to a point of interest is projected perpendicularly into a reference plane, the angle between the projected vector and the reference vector on the reference plane is called azimuth. So here the azimuth is clearly visible. As we said in the definition, the angle between the projected vector and the reference vector on a reference plane. So the next definition, solar azimuth angle, normally denoted as gamma s. Solar azimuth angle is the azimuth angle of sun's position. It is the angular distance between the zero azimuth and the projection of the line of sight to the sun on the ground. It is measured clockwise from zero azimuth. In short, we can say that it is the distance between the zero azimuth and the projection of line of sight to the sun on the ground. Next definition is the surface azimuth angle. It is defined as the horizontal angle between the projection of the normal to the horizontal surface and the north-south line. Surface azimuth angle. The angle between the normal to the surface from true south. Tracking arrays follow the sun to maximize the incident beam radiation on the surface, and the tracking control is based on the angles of incidence and surface azimuth angle. The angle made by the plane surface with the horizontal is denoted by the term called slope, and the length of the day, it is a function of latitude and solar declination. It is represented as TD equal to 2 by 15 cos inverse minus tan phi tan delta, where phi indicates the latitude and delta indicates the declination. Now the next definition, local solar time, or simply solar time. It is the time according to the position of the sun in the sky relative to one specific location on the ground. In solar time, the sun is always due south or north exactly at noon. Local solar time is given by an expression. Local solar time LST equal to standard time plus or minus 4 into standard time longitude minus longitude of the location plus equation of time correction. The standard time longitude can be taken as Indian standard time is calculated on the basis of 82.5 degree east longitude in the city of Mirzapur, that is Uttar Pradesh, which is situated approximately on the corresponding longitude reference line. Here explain some of the terms related to solar radiation geometry. The main references include non-conventional energy sources by G.D. Roy and some websites. some terms and matters related or collected from the websites. Thank you.